All right. Good morning. We're going to talk about the metric system. This is the units or the system of measurements that's used in science. In French, it's also called, or French, it would be called SI or System International. We typically just call it the metric system. The metric system is used worldwide for measurement. All scientific disciplines use the metric system. If you've gone and got yourself actually like weighed at the doctor's office recently, did they measure you in kilograms or pounds? Do you guys get weighed recently? Like for physicals? What? Kilograms. Okay, so medical, I guess, field, we typically use metric as well. We just don't really realize it. But if you dose medicine, it's given in milliliters or cc's. That's metric. That is not English. So the question is, why do we use the metric system as opposed to using the imperial or English system? One reason is just that everyone else in the world uses this. They've adopted this. In fact, the official measurement system since the 70-something is the metric system. Like, that is our official unit. But in standard generalized practice, we still do use like feet and gallons and so forth in kind of our standard daily lives. We're familiar with it. We're not as familiar with the metric system, even though if you look on any food packaging, you'll see that it's given not only in ounces, but also milliliters, right? So that's your standard imperial measurements and then your metric measurements. The real reason is, why do people use the metric system other than, it's just, widespread? Why is that? And that probably has a lot to do with converting between units and the ease with which you can do that. So in the metric system, there are some base units, and those base units are, how many markers? Meters, liter, and gram. There are other base units. Is that visible?
No.
It is now. No, we can just move it. Meter. Okay, liter and gram. All right, and so these are some base units. There are other base units for other things you need to measure, right? What do meters measure? Length, right? How long something is. Liters measure volume. Volume is the amount of space something takes up. So that's why you would buy like a 2-liter bottle of soda. That's a amount of something. And then gram measures what?
Weight.
Okay, is weight and mass the same thing? No. Grams measure mass. Now, yes, on Earth, that we kind of is an equivalency, but keep in mind that technically weight is the amount of gravitational pull on you. If you change gravity, you change your weight. If you go to the moon, you weigh 1/6 of what you would weigh here. So you step on a scale here, you step on a scale on the moon, you would be 1/6 of your weight on the moon. Weight changes. Does mass change? No, because mass is the amount of matter in an object. If I go to the moon, I have the same amount of stuff inside of me here as I would there. There's no difference, okay? And mass influences your amount of inertia and all this other stuff, okay? So these are some of our base units. If we were going to measure other things like temperature, it'd be Celsius. If we'd measure, electrical resistance or some other thing you'd want to measure, it would be other units. These are the ones we primarily deal with. So these are our bases. And the cool thing is, in a base, if I'm measuring distance, I can convert between the size of the units that I'm going to use simply by adding a metric prefix to it, and I can adjust my measuring stick to the most appropriate size. Like a meter, which I have to do that meter stick. A meter is great, but not if I want to measure my marker. It's way too big. So I would need a smaller unit to measure this. Just like if I was measuring something even with English measurements or imperial measurements, measuring something as a foot is great unless it's small, and then I'd want to use inches, right? And so how do we convert from this big meter to a smaller unit? And that's the most usable thing about the metric system, is that you're always just multiplying or dividing by a power of 10. So we do this by adding our metric prefixes. Okay, so we're going to do by powers of 10 from our base. We can go 10, 100, or 1,000 times that base, or 1/10, 1/100th, or 1/1000th of that base. So we can divide, by using metric prefixes, we can divide this into smaller units or make it a much bigger unit. And here's where that really divulges from your imperial measurements. When we're converting between like inches and feet, how many inches are in a foot? There's 12. How many feet are in a mile? 5,280. How many feet are in a yard? 3. How many yards are in a mile? Okay, you're pretty good. How many feet are in a chain? I don't either. There's chains and rods and all these other measurements, and we don't have any idea. How many cups are in a pint? 2. How many ounces in a cup? 8. How many pints in a quart? 2. How many quarts in a gallon? 4. How many gallons in a bushel? 8. Whoa, okay, so there's no standard conversion in any of our English measurements. Like, nobody really remembers all of that, right? And so they're all different. With metric, it's always exactly the same. I want a bigger unit or a smaller unit to measure volume or length or mass. All I have to do is adjust it using some power of 10, and we're really good at multiplying or dividing by 10. So it makes it pretty easy to do, right? So if I want to adjust my basic meter to something smaller or larger, I simply stick on the appropriate metric prefix and it makes it that size of measurement unit. And we know that that measurement unit is either 10 times that base or 1/10 of the base. So your metric prefixes. Some of these you will never really use in real life. Others you'll just see every once in a while in science, but some are really rather common. Okay, so 1/10 of something is a deci of something. 1/100th is a centi, like a centimeter, you're familiar with that. And then milli is 1/1000th. 10 is a deca of something. 100 is a hecto of something, and 1,000 is a kilo. So we're used to seeing something's in kilometers or familiar with kilograms. This is something 100 of a liter, or excuse me, 1,000 liters or 1,000 grams would be a kilogram. All right, grams are pretty small. It's like a paperclip. So you definitely wouldn't want to find your mass with paperclip size units. That's not appropriate. So instead, you want to use kilograms, and then that would then be more appropriate to measure your particular mass, right? If you want to measure something really small, like an insect, you might want to just use grams. Or medicine, when you take medicine, look at dosages on medicine, it's in milligrams, because you only need an incredibly small amount of that medication for it to have an effect. Like an extra strength Tylenol is 500 milligrams of acetaminophen per tablet, right? That's a really small amount, but that's all you need, right? We wouldn't want to measure that in grams or kilograms. It'd be way too much. Okay, so those are our units, and we can use any of these bases and then adjust the size by adding our metric prefixes. You will probably never use, I'll be very realistic, you'll probably never use hecto or deca, at least very rarely. We use kilo all the time. We use centi and milli quite often, but we rarely use deci. So I could measure something in decimeters, which is every 1/10 of this meter stick. That's a decimeter, right? Or I could measure 1/100th of the meter stick. That's a centimeter. Or I could measure using thousandths of this meter stick, which these little itty bitty little marks, 1 millimeter, right? So there's 10 millimeters in a centimeter, 10 centimeters in a decimeter, and 10 decimeters in a meter, right? So it's all by tens, and I can simply adjust the size of my units to make it most appropriate to use for what I'm doing, right? Okay, so now we need to talk about how do you convert between this, and this is where we need to get a little technical. So this is a process known as dimensional analysis, and you've maybe kind of done this before. You've definitely done all the metric stuff before, but the dimensional, let's see. So dimensional analysis is you're analyzing dimensions, like the spacing of things, if you will. And so this is just simply a technical way to set up converting between units. You don't change the actual measurement, you change the unit used to measure that thing that you're measuring, if you will. All right, and so I'm going to show you the way to set this up and do this. Now, why is this even important? Because that's the question we get. You guys are really good at doing math in your head by multiplying or dividing by 10. If you're familiar with the metric prefixes, it's going to be really easy for you to be like, yeah, there's like so many centimeters in a meter, I can figure out this measurement in my head. And that's totally fine. But I want you to know the process of how to do the dimensional analysis, because it will be very useful to you in any other science class from here on out. You do this a lot in chemistry. You do this in physics a lot. You do this in any other higher science when you're converting. Nursing does a lot of this when they're figuring dosages. So knowing the process to me is more important than maybe just being able to come up with a final answer. Wow, it's almost sounding like math, isn't it? Is that what you hear? Did your math teacher say that? Mm-hmm. No, they just want the right answer? Yeah. Okay, so this is the process. So in dimensional analysis, let's say we want to have a question about so many units to so many other units. So I have 325 centimeters. I want to know how many meters that is. So how am I going to solve this? Setting it up from a dimensional analysis standpoint, we can kind of figure out whether we should multiply, whether we should divide, and by how much. This is the important part. So I'm going to go ahead and put 325 over 1, and I'll put centimeters. This is just a math problem. Then I'm going to multiply this by an equivalent fraction. So an equivalent fraction is something over something, like 1 over 1 is 1. But 100 over 100 is also 1, right? And we can multiply anything by 1 and you still have the same amount, right? Like a billion times 1 is still 1. Oh wait, it's still a billion, right? It's the same amount. I used the wrong number, okay? So by making an equivalent fraction, I'm really multiplying something by 1. So I'm not changing the actual measurement. What I'm trying to do is change the unit to measure whatever that measurement is. No matter whether this rock, this piece of calcite, whether I find its mass in grams or kilograms or milligrams, does it all weigh the same or have the same mass? Does mass change? No. I'm just changing the unit I use to find its mass. Okay? So I'm looking at this metric prefix, little lowercase c, that's centi, that means what? 100 or 1/100th? Okay, so if I want to convert to meters, it's from centimeters. How many centimeters are in a meter? 100. Because if it's a centimeters, 1/100th, it'd take 100 of them to equal 1 meter. So 100 centimeters and 1 meter are exactly the same thing, right? Because that's right here. There's 100 and 1. Centimeters, meters. It's exactly the same. So that's equivalent. So I could multiply this number times 1 and not change anything. So I'm going to make an equivalent fraction, which is equal to 1. Now, here's the trick. What are you going to? I am going to meters, so you want to put meters on top. So 1 meter and 100 centimeters are exactly the same amount. That's like multiplying by 1. Okay? Because I want to go to meters, we put that on top of our equivalent fraction. You remember that. Then, at that point, it's just math. Because I've set up the appropriate equivalent fraction with the unit I want to go to on top, I can just do my math problem and it will tell me the answer. It allows me to cancel out my centimeters. You guys get to cancel out units if they, like in math, if they're across from each other, right? So it's no different. I'm going to cancel out my centimeters. and then I'm going to do the math. So 325 over 100, okay, which is going to give me what? I didn't lose my meters, so I get to go 3.25 meters. Right? Now, how many of you like totally knew right when I wrote this down what the answer is? Like you knew those units. Yeah, cool. But the deal is that by setting it up like this, it always will show you, and this is where people get confused. Do I multiply or divide, and by how much? If you make your equivalent fraction and always put what you want to go to on the top, you will know whether you should multiply or divide, and you will know by how much, okay? And that's why this is important. All right, let's look at another one. So we went from a smaller unit to a bigger unit. Let's go from a bigger unit to a smaller unit. Okay, so if I have 6.9 grams, that is equal to how many milligrams? Okay, so I'm going to put 6.9 grams over 1 times, what's my equivalent fraction? Grams, milligrams. How many milligrams are in a gram? Milli, that prefix?
1,000.
It's a 1,000th, so there must be 1,000 of them in 1 gram. Right, so my equivalent fraction is 1,000 over 1. I want to go to milligrams, so there is 1,000 milligrams in 1 gram. Now I'm ready to do the math. Get rid of my grams, multiply 6.9 times 1,000 is 6,900 milligrams. Oops, I don't even need a line. That's it. Notice last time we divided, this time we multiplied. We knew what we should do by how we set up our fraction. We wanted to go to milligrams, we put it on top. Okay? You don't even have to use metric for this. You can use time. How many, let's see, 3.5 minutes equals how many seconds? Right, we can do this. 3.5 minutes for 1 times, what's my equivalent fraction?
60.
There's 60 seconds in 1 minute. 60 over 1. Cross out minutes. 3.5 times 6 is 1821. 10 seconds. Did I do that right? I think so. All right, so there you are, okay? All right, so that's dimensional analysis when I say that, and we'll practice this more later. But that's what I'm talking about when I say dimensional analysis.